Hello everyone! So today I'm going to talk to you about the substitution method. This is used to find the point or points where two functions intersect each other. Let's look at two linear equations. The first one, y equals 2x minus 3. The second one, y equals negative 4/3 x plus 7. Let's look at these two on a graph. The orange line is y equals 2x minus 3. And the yellow line is y equals negative 4/3 x plus 7. You'll notice that the two lines cross each other at this point. We want to figure out what coordinate point that is. Now, you might think I can just look at the graph to find the point, but the problem with that is graphs can be deceiving. We don't know if this point is exactly where it appears to be. Especially with the scaling of the graph, we can't tell exactly where it is. To find the coordinate point, we want to solve the equations algebraically. There are a few ways to do this, but I'm going to focus on the substitution method. Our goal is to substitute one equation into one of the variables of the other, hence the name. This allows us to have one equation with one variable. Here's how it works. The first step is to isolate one variable. Both equations have the y by itself, so we're good to go. If we wanted the x alone, we would have to do extra steps, like on this one, you'd add 3 to both sides and then divide both sides by 2, but since y is already alone, let's just leave it the way it is. The next step is to plug in the isolated equation into that variable in the other equation. Since both have a y isolated on both equations, it doesn't matter which one you use, so I'm going to plug in this first equation into the second one. Anytime we see a y in the second equation, we're going to plug in 2x minus 3 for that y, since we are given y is equivalent to 2x minus 3. So here's our y. We're going to plug in 2x minus 3 into that y, like so. The third step is to solve. We want to get the x by itself. Remember, when you're solving algebraic equations, you have to perform the opposite operation on both sides to cancel it and keep it balanced. I'm going to start by adding 3 to both sides. See, originally we were subtracting 3, so adding 3 will make this part cancel out and equal 0. We have to do it to both sides, otherwise it becomes imbalanced. Now we have 2x equals negative 4/3 x plus 10. We want to combine the x's by adding 4/3 x to both sides. Now, you could subtract 2x over, but then you have to move the whole thing back to the left side, so it's easier just to add 4/3 x. These cancel out. 2 plus 4/3 equals 10/3 x, which equals 10. The last step is to multiply both sides by the reciprocal, so we can get the x by itself. The reciprocal of 10/3 is 3/10. These two cancel out. When we simplify, we get x equals 3. This is the x-coordinate of the intersection point. To find the y-coordinate, you have to plug in the answer into the equation. We got an answer of x equals 3, so we'll substitute in 3 for x. Doesn't matter which one you plug it into, you should get the same answer no matter what, but I'm going to plug it into this first equation since we don't have to deal with that fraction there. Anytime we see an x in our equation, we're going to plug in 3, since that's what we found x equals. So here's an x. We're going to plug in 3 into that x, like so. 2 times 3 is 6, minus 3 is 3, so we get an answer of y equals 3. The intersection point of y equals 2x minus 3, y equals negative 4/3 x plus 7 is 3, 3. Going back to our graph, you see this makes sense. You can tell the lines intersect at the point 3, 3. Here's another example. Negative 3x minus 2y equals 20, and y equals 4x plus 1. We want to find the intersection point between these two equations. Our first step is to isolate one variable. You'll notice the first equation doesn't have a variable isolated, but the second one has the y by itself. It would be easier just to plug in this equation into this one, since we don't have to do an extra step to isolate the variable. So since we already have a variable isolated, our next step is to plug in the isolated equation. Anytime we see a y, we want to plug in 4x plus 1. So here's a y. We're going to plug in 4x plus 1 into that y. The next step is to solve. First, let's distribute this negative 2 into the parentheses. Negative 2 times 4x is negative 8x. Negative 2 times 1 is 1. Here's our negative 2. Here's our new equation. Now let's combine like terms. Negative 3x minus 8x is negative 11x. Now we're going to add 2 to both sides to cancel. These two cancel. Now we're going to divide both sides by negative 11. These two cancel. When we simplify, we get x equals negative 2. We just found our x coordinate. So now we want to plug in our answer into the equation to find the y coordinate. We got x equals negative 2. You can plug it into either equation, but I'm going to plug it into the isolated equation since it's easier to simplify. Here's an x. We're going to plug in negative 2 into that x. 4 times negative 2 is negative 8, plus 1 is negative 7, so we get y equals negative 7. The intersection point between these two equations is at the point negative 2, negative 7. You could graph this to verify if you wanted. Here's our last example. Negative 7x minus 2y equals negative 13, and x minus 2y equals 11. Our last few examples had a variable isolated already, so we could essentially skip this first step. Now we don't have a variable isolated, so we have to get one isolated. Doesn't matter what variable or equation you use, but I would look for the one that has the least amount of steps. I'm going to isolate the x on the second equation. You add 2y to both sides. These cancel. And then that's it. X equals 11 plus 2y. Now we have an x isolated. Now try to solve this on your own because the steps are exactly the same as before. Pause the video and then come back and check your answer. Okay, we're back, so let's see how you did. You probably started by plugging in 11 plus 2y into the x in the first equation, like so. When you solve for y, you got y equals negative 4. Then you plugged in negative 4 for y. I'm going to plug it into our isolated equation. When you simplified, you got x equals 3. Your coordinate point should have been 3, negative 4. Remember, you solved for y first. The first number you find is not always the first number in our coordinate point. Just pay attention to what you're solving for. That's all I have for today. Thanks for watching.